Hello, I'm Lou, VK3AQZ. This is my latest homebrew project. It consists of 4 units, an MP3 player which can play back MP3 files such as calling CQ, and a stairstep which I can use for tuning up the linear. A 2-tone oscillator for testing intermodulation distortion in my transmission homebrew equipment. A small monitoring system consisting of a oscilloscope which can work at audio frequencies and at RF. At RF I have a detector circuit in there and it's tunable from 1 to 30 megs. Down here we have a speech processor. It consists of 2 microphone inputs and can go to 2 rigs. Input selector, AGC, 5-band speech equalizer and a split band compressor with 4 bands. It also contains a small amplifier for either speakers or headphones and a small spectrum analyzer. This is the 2-tone generator. It uses AD9833 chips. Performance is minus 60 dB distortion and noise. This unit contains 2 independent tone oscillators, and each of the tone oscillator outputs can be varied by these controls, and the 2 can be combined to form a 2-tone test signal. For this demonstration I'm using a power bank to power all the modules. It contains a couple of USB-C outlets and it's programmable. I'm using a decoy module to set the output to 12 volts. That's down here. Otherwise you'll only get 5 volts out of the unit. It's quite good. It's made of metal and well shielded. Each oscillator can be moved up and down in frequency in either 1 cycle steps, 10, 100 or 1 kilohertz. It'll go up to 10 kilohertz and down to 1 cycle. Each oscillator can go into a sweep mode. I can turn that on. At the moment I'm sweeping in 10 cycle steps. I can step that up to 100 cycle steps. It'll sweep up to 4 kilohertz so that I can pass it through, for example, a transmitter filter. The level is adjustable in decibels or millivolts peak to peak. That's millivolts peak to peak. This particular display can also be used to measure the output level for the combined 2 oscillators, the 2 tones that can be used for testing, 2-tone testing of a transmitter. Both oscillators are completely independent. I can also vary the phase as well as the frequency, and I'll show you that on the oscilloscope in a moment. So switching to phase, you'll see the display change to PST phase steps. Phase step is 0. If I push the step up to 1, it'll now change in 1 degree steps, as you can see. Or I can go in 30 degree steps. They're just values I've picked. 90 degrees, 180 and then back to 1. Here's an internal view of the box. It's quite busy. I could open it up, but here's a photo. It contains 2 separate Unos and 2 separate AD9833 oscillators. The 9833 only has 1 output, so you can't put 2 tones out simultaneously, so you need two separate chips. Buffer amplifier. Up here we have an AD8307, a pair of them, which are log linear detectors, and these are used for the output level display. They're log linear, so you get a fairly accurate output level. Here's a quick look at the circuit. It contains an Arduino Uno driving the 9833 and a buffer amplifier. Down here we have the OLED display and a series of control buttons and switches. Here's the waveform outputs on the Crow, the 2 F1 and F2 signals. What I will show you is the phase shift of 1 tone compared to the other one. So using the same frequency for comparison, I'm just going to step up in 30 degree steps first. There's 30 degree shifts, and then I'll go 90 degrees. You'll see a 90 degree shift. There we go. And then 180 degrees. And we've reached the limit, so we go back down that way. That's 180 degrees. And we can go back to 1 degree. Now 1 degree is a very small change. You'll see the bottom blue trace slowly move up in 1 degree steps. You'll see it move away from the vertical axis line. There we go. So that's the phase adjustments on one of the tones. So there's a demo of the frequency sweep. You can hear that. It's 100 cycle steps, 1 kc steps, and 1 cycle, and back to 100 cycle steps. There's the spectrum. As you can see, it's quite clean. We're down at 60 dB at that baseline. I'll just sweep it. That's the sweep. So there's the two tones sweeping together, and there's the spectrum of the two tones moving together in sync. There's a view on the little crow. The little crow's quite handy. I'll come in a bit lower. I'll just stop the tone at some frequency. Just step down. We can push this button. We can push the little yellow button here and read off the values. Frequency, amplitude, etc. And we can change the time base. We'll get rid of the display now to suit. Quite neat little device actually. Just runs off 6 volts. And I've got a control here for the level on the side of the box. And it's got more adjustments inside the top of the circuit board. You can get to some tiny switches up there. Here's a quick look at the circuit of the little monitor device I've got. It's the small DSO 138 oscilloscope and a circuit of the RF portion, which is simply basically a crystal set with a diode detector and a number of taps on a coil, which allows me to tune from 1 to 30 megahertz. Here's a photo of the inside. There's the back of the DSO, and here is the coil used for the tune circuit. It's got 4 taps. Pretty simple circuit, Varicon tuning capacitor, and a diode that feeds a switch which can switch between audio input or rectified RF output. This little crow has a number of functions. Most of them are selected by operating some of these buttons, either 2 buttons together or one on its own. One of the interesting features is it can stop the waveform, store it into an EEPROM, and then you can download it into your computer using the USB port. I have stuck on the side of the box some of the instructions that you get by pushing various buttons. For example, save waveform, press select and the plus button simultaneously, and the currently displayed waveform will be saved in EEPROM. So they're just there as a reminder. Here's an example of that feature where I can freeze the waveform. I've just got the stairstep going through the transmitter. I've tuned it in on the tuner on this little box. And now if I want to have a close look, I just hit the yellow button and it will freeze. There we go. Now if I like, I can expand that out a little bit. I can unfreeze it and I can change the time base like that and have another go. There we go. So that's an interesting feature. That frozen waveform can then be sent to the computer. And as I demonstrated earlier, you can also bring up the information about the waveform. Frequency, voltages, peak to peak, etc. And freeze that and have a bit of a read. So that's a very useful feature on this little tiny crow.